Hi, I'm Dr. Jess Wade, a Royal Society University Research Fellow and lecturer in the Department of Materials here at Imperial College London, and I'm joined by Professor Sir Peter Knight, Emeritus Professor of Physics here at Imperial, UK's Chief Quantum Advocate, I gave him that title, and also godfather of the UK National Quantum Technology Programme. Hello, Sir Peter.
Hello, Jess, and great pleasure to be here.
We've had huge excitement for the last year for the celebration of the International Year of Quantum Science and Technology, which Peter helped to lead and set up globally as a recognition of 100 years since the development of quantum mechanics. I wonder, Peter, if you could tell us a little bit about the year and also what it was celebrating.
What we're celebrating is the way that quantum, which is a pretty abstract concept, has transformed people's lives. It's brought all sorts of benefit to people right around the world.
Could you tell us a little bit about what quantum actually means? Everyone watching this might have heard of it or been celebrating throughout the past year, but not really know what it means.
Quantum is the science of the very small, usually. The very small in the sense that we're looking at atoms and photons and the basic constituents of matter, but manipulating them in such a way that we can get useful benefit from them. I think that it will affect our way that we compute, we move information around, how we sense the world around us as well. But already, the benefits for this, broadband is enabled by quantum, the phones, the imaging systems, all the things that we take for granted, semiconductors, lasers, the way that we do all sorts of things like brain scanning, these are all quantum enabled. What we're moving into that next revolution is going to be transformational as well.
Happy 2026. We're going to be here celebrating your Quantum New Year's resolution. So what successes from 2025 can the quantum community build on for the new year?
The big success that we've seen in the last year is given us confidence that we can build quantum machines at scale. That this really means that we can pursue that journey to do something of substance. Over the past 18 months, in particular, working out how we do error correction. That means that we know that we're on the right pathway.
And what do you think is going to be big for quantum in 2026?
In 2026, what we will see is moving from concept to product. We'll see a commercial success for this intellectual adventure.
And what goals do you want the quantum community to have solved by the end of 2026, and what kind of obstacles do you see coming in their way?
The biggest obstacle, I think, in realizing the success of this for a place like the UK is going to be patient capital, of how we actually see ways in which we can keep it homed, sticky in the UK.
And when you speak about the kind of stickiness, is that keeping UK quantum companies in the UK?
I think as long as you keep the scientific adventure going, then the pipeline is such that you'll carry on doing this stuff. It's not enough to say you've done the science, now just do the engineering and make it. That's not how it works. What we need to do is to make sure that pipeline of discovery, of moving the subject forward continues for the decade. And that's where I'm fairly confident that in the UK we've got that one right.
So Sir Peter, I wonder how you actually see quantum benefiting people in the real world.
One of the things that we know is a longer journey, but that have an enormous impact, is quantum computing. Quantum computing has the ability to do things in a transformational way. If I could have 300 of our quantum bits under control, the state space that I can access is greater than the number of particles in the visible universe. We've only just started to explore what that will do in terms of understanding chemical dynamics, drug discovery, optimization, all sorts of things which will be influenced by that. That's a longer journey. How is it going to affect people next year? We're going to do brain imaging, functional brain imaging, using quantum coherence to actually map out decision making in the brain.
So pretty much every sector of UK society will be impacted by quantum technologies.
It will affect health, it will affect all sorts of things. Imagine you're a citizen of the UK. You wake up in the morning, what's the first thing you do? You check your email, probably.
Okay, I was going to say brush my teeth, but you can go and
check your email. That's enabled by quantum physics, okay? Then you do go away and brush your teeth, and then eventually you go to work, and you probably program your phone for the GPS to get there. GPS is enabled by atomic clocks, okay? That whole journey from waking up to getting to work has been quantum enabled. We're going to continue that.
Fantastic. So, Sir Peter, we've asked you to bring something along that was important in your quantum journey. Do you want to show everyone?
Well, one of the things in quantum that we have is a battle between temperature and the quantumness of things. The world is warm and tends to muck up all the quantum stuff. If only the signature of quantum was a bit bigger, it would be easier. So what the guys in the workshop here at Imperial did for me is to say, quantumness is determined by Planck's constant, h bar. So they made me a really big one.
They made you a giant H-bar.
A giant H-bar to make quantum bigger.
I like the thought of how many government ministers that's been in front of, convincing them to fund the UK's quantum programme.
That's been at number 10, it's been at number 11, it's been in Parliament. It's a nice way of showing what we're trying to do. The balancing act between temperature, which is the disruptor, and quantum, which is the enabler.
Yeah, well done to the physics workshop for making that possible. Thank you so much, Professor Sir Peter Knight, for joining us today and for everything that you've done for the UK's National Quantum Programme and the Global Quantum Programme.
It's not over yet. There's lots more to do, and I'm looking forward to being part of it all.
Thanks so much. And thanks so much to everyone who's been watching us on YouTube. This is part of Imperial's celebration for the International Year of Quantum, but also the quantum future. And we really hope that you're part of our journey.